Download this code from codegive.com, link in the description below. OK, let's dive into the Don't Fail Like This driving test fail light project. This project involves creating a visual indicator, a light, that illuminates when a simulated driving error is detected. It's a fun and educational project that can be used for mock driving tests to help aspiring drivers practice and become aware of common mistakes. Educational demonstrations to illustrate how sensors can be used to monitor driving behavior. Hobby projects to learn about Arduino programming, electronics, and sensor integration. We'll cover the hardware requirements, the Arduino code, and how to build and test the system. Overview of the project. The basic idea is this. 1. Simulate driving errors. Will use buttons, or potentially more sophisticated sensors in a future iteration, to represent common driving errors, such as speeding, not signaling, rolling stop, ignoring a traffic light. 2. Arduino control. An Arduino microcontroller will monitor the state of these error buttons. 3. Fail light indication. When a button is pressed, representing an error, an LED, or a group of LEDs for a more visually prominent fail light, will illuminate. 4. Optional features. We can add features like buzzer/sound, an audible alert to accompany the visual one. Error counter, keep track of the number of errors made during the simulated test. LCD display, show the number of errors, the type of error, or a passing/failing message. Sensor integration, incorporate real sensors like an accelerometer, to detect jerky movements, or a distance sensor, to detect following too closely. Difficulty settings, make errors more or less sensitive. 2. Hardware components. Here's a list of the components you'll need. Arduino Uno, or similar, the microcontroller that controls everything. LEDs, light-emitting diodes for the fail light. Red is a good color choice. You can use a single bright LED or several smaller LEDs wired in parallel for greater visibility. Resistors. Current limiting resistors for the LEDs. Typically 220 ohms to 1k ohm depending on your LED's voltage and current rating. Calculate the correct resistance using Ohm's law. R equals Vs, Vf/I, where Vs is the source voltage, 5V, Vf is the LED's forward voltage, typically 1.8 V to 3.3 V, and I is the desired current, typically 10-20 mA. Pull up or pull down resistors for the buttons. Typically 10k ohm. If using internal pull up resistors, you don't need these external resistors. Buttons, momentary push buttons to simulate the driving errors. You'll need one for each error you want to simulate. Breadboard for prototyping. Jumper wires to connect the components. Optional, buzzer for audible alerts. Optional, LCD display, 16:2 or similar for displaying information. Optional, accelerometer, example MPU 6050 for detecting jerky movements. Optional, distance sensor, example ultrasonic sensor for detecting following too closely. Optional, potentiometer to control sensitivity. 3. Wiring diagram. Here's a simplified wiring diagram. Note that the specific pins you use can be changed in the Arduino code. Important notes on wiring resistors. Always use current limiting resistors with LEDs to prevent them from burning out. Asterisk polarity asterisk LEDs are polarized. The longer leg is the anode, plus, and should be connected to the positive side of the circuit, through the resistor. The shorter leg is the cathode, and should be connected to ground. Asterisk button configuration asterisk the diagram shows a pull-down configuration. When the button is not pressed, the digital pin is pulled low, to ground, by the 10K resistor. When the button is pressed, the digital pin is connected to 5V, making it high. You can also use a pull-up configuration where the resistor is connected to 5V and the pin is pulled high normally. In that case, pressing the button pulls the pin low to ground. The code will need to be adjusted accordingly. You can often use Arduino's internal pull-up resistors to avoid needing external ones. 4. Arduino code. Here's a basic Arduino sketch to get you started. This code includes the LED, buttons, and optional buzzer. It uses internal pull-up resistors for the buttons. Explanation of the code asterisk. Asterisk define or constant asterisk these lines define constants for the pin numbers. Using constants makes the code more readable and easier to modify. Asterisk pin mode, asterisk this function sets the mode of a digital pin. Output means the pin will send a signal, example to turn on an LED. Input underscore pull-up sets the pin as an input and enables the internal pull-up resistor. This means the pin will be high by default, and will go low when the button is pressed. Asterisk digital read, asterisk this function reads the digital value of a pin, high or low. Asterisk digital write, asterisk this function sets the digital value of a pin, high or low. Asterisk tone, and no tone, asterisk these functions control the buzzer. Tone generates a square wave at a specified frequency, which creates a sound. No tone stops the sound. Asterisk delay, asterisk this function pauses the program for a specified number of milliseconds. Asterisk serial.begin, and serial.print, /serial.println, asterisk these functions initialize and use the serial communication for debugging. You can view the serial output in the Arduino IDE serial monitor. Asterisk error count asterisk keeps track of the number of errors. V building and testing. 1. Connect the components asterisk use the breadboard and jumper wires to connect the Arduino, LEDs, resistors, buttons, and buzzer according to the wiring diagram. 2. Upload the code asterisk copy the Arduino code into the Arduino IDE. Select the correct board and port from the Tools menu. Click the Upload button to upload the code to the Arduino. 3. Test the system asterisk press each button and verify that the fail LED lights up, the buzzer sounds, and the error is printed to the serial monitor. 6. Adding features, optional. Here are some ideas for expanding the project. A LCD display. To add an LCD display, you'll need to include the liquid crystal.h library and connect the LCD pins to the Arduino. Modify the code like this. B. Error counter and passing / failing logic. Modify the handler function to increment an error counter. Add logic to the loop function to check if the error count exceeds a threshold, and display a pass or fail message on the LCD. C. Accelerometer, jerky movements. To use an accelerometer, like the MPU 6050, you'll need to include the appropriate library, example wire.h and the MPU 6050 library. Connect the accelerometer to the Arduino's I2C pins, SDA and SCL. Read the accelerometer data and look for sudden changes in acceleration that indicate jerky movements. D. Distance sensor, following too closely. To use a distance sensor, like an ultrasonic sensor, connect it to the Arduino and read the distance. If the distance is below a certain threshold, trigger the fail light. Potentiometer, sensitivity adjustment. Connect a potentiometer to an analog input pin on the Arduino. Read the analog value from the potentiometer and use it to adjust the sensitivity of the sensors or the error threshold. 7. Potential improvements. Realistic simulation. Instead of just using buttons, try to integrate sensors that provide more realistic data, example a steering wheel potentiometer, brake pedal sensor, etc. Wireless communication. Use Bluetooth or Wi-Fi to send the error data to a remote device, example a computer or smartphone. Data logging. Store the error data to an SD card or transmit it to a database for analysis. More sophisticated scoring algorithms. Weight errors differently, allow for minor errors and grace periods. 8. Conclusion. This Don't Fail Like This driving test fail light project is a great way to learn about Arduino programming, electronics, and sensor integration. By building and modifying the system, you can gain a better understanding of how sensors can be used to monitor driving behavior and provide feedback. Remember to have fun and experiment with different features and improvements. Good luck.